Hi and welcome to this lesson on quadratic equations. In this short session, quadratic equations will be introduced. The key thing to note about quadratic equations at this point is that they are equations, therefore they are statements that tell you that a term is equal to another term, or a bunch of terms is equal to a term, or a bunch of terms is equal to another bunch of terms. The simplest form of equation you would ever come across, a simple example of an equation, for instance, is the equation x equals 1. It really doesn't get simpler than that. This is a statement. It tells you that a term on the left hand side, x, is equal to a term on the right hand side. That's what this is. That's an equation. Equations can get a bit more complicated. You can have something like this: x plus 3 is equal to z, where z is a variable, x is a variable. Again, the fundamental point is that an equation tells you that it's a statement that tells you that a left hand side term or bunch of terms is equal to a right hand side term or bunch of terms. So you know that a quadratic equation is an equation. Good, very obvious thing. Now the key thing about quadratic equations are that they are equations that take a very specific form, and they are equations of the form y equals ax squared plus bx plus c, where y is a variable, x is a variable, so don't worry about that for now, but x is a variable and x squared is therefore a variable because x squared is x times x. So this lesson assumes you've covered the topic of indices. Anyway, but one condition is that quadratic equation is an equation of this form where a is not equal to 0 is a quadratic equation. So that's the key thing. So I'm going to give you some examples of equations that are quadratic because they are of this form, prescribed form, and they satisfy this condition. Okay, let's take the equation y equals 3x squared plus 2x plus 1. Now, just by glancing at this given equation, so I'm going to call this equation 1, and comparing it to the general form, so this whole, stop it here, is the general form of quadratic equations. So I'm just going to general form for quadratic equations. Now, just comparing equation 1 to general form, you can tell that a is 3, b is 2, and c is 1. Now, x squared is a variable term which appears here and also appears here. The coefficient of x squared here is 3. The coefficient of x squared in the general form is a. Therefore, this equation is a quadratic equation, or let's put it this way, this equation is such that its a term is 3. Similarly, the coefficient of x here is b, the coefficient of x here is 2. This equation is an equation such that the coefficient of x is 2, so b is 2. This equation has a constant term, so does this one. C is 1. That's all we've done. Very simple inspection. But the proper way to do this is to note from your lesson on indices. If you haven't covered indices, I would refer you to the video on indices. Is to note that when you raise a variable or a number to the power of 0, you get 1. So for instance, 2 to the power of 0 is 1. The variable x to the power of 0 is 1. So if I tell you, or if I write something like 2, and I say, actually, let's write 2x to the 0. 2x to the 0 is 2 times x to the 0. X to the 0 is 1, so 2 times 1 is 2. And this applies to anything, any number. 4 times x to the 0 will be 4 times x to the 0, which is 4 times 1, which is 4. Anything multiplied by x to the 0 is simply a case of multiplying it by 1. So it's in front of you, know that. So I'll just put that here. X to the 0 is 1. You learn this from the topic of indices. Given what was just said, the general form can be written as this equation here. I'm going to put an asterisk next to it. All that has been done is a replacement of this c term with c times x to the 0. because this is the same thing as c, because x to the 0 is 1. That's all that has been done. So no rule has been broken. So if you consider this to be the general form of a quadratic equation, we now have 3 x terms on the right hand side. 1 raised to the power of 0, 1 raised to the power of 1. You know, x to the 1 is x. So that's not shown. But I'm just going to show that now, and I'm not going to show it again. And we have x to the power of 2. Now, if you're asked to determine whether an equation like y equals 6x squared plus 4x plus 2 is a quadratic equation, good thing to do will be to just replace the 2 with 2x to the 0 so that it matches this form, this new form, this equation, this asterisk equation. The utility of this, or the usefulness of this rather, is that you can easily determine the values of a, b, and c for the given equation just by comparing the coefficients of the variables involving x. So, for instance, if you're comparing the coefficients of x squared, in this is, you know, a modified general form, and this is the given equation. If you compare the coefficient of x squared, you can tell that for this equation, a is 6 just by comparing the coefficient of x squared. We have x squared here, the coefficient is a, x squared here, the coefficient is 6. We have a plus sign, we have a plus sign. We have the coefficient of x here as b, coefficient of x here is 4. So for this equation, b is 4. The coefficient of x to the 0, okay, we have a plus sign, we have a plus sign. The coefficient of x to 0 here in the given equation is 2. Coefficient of x to 0 in the general form is c. So for our given equation, c is equal to 2. So what I'm just trying to say is that this equation, y equals 6x squared plus 4x plus 2x to the 0, or 6x squared plus 4x plus 2, is a quadratic equation, or it's an instance of this general form where a is 6, b is 4, and c is 2. Let's consider one more example now. Is the equation y equals 5x squared plus 2x minus 1 quadratic? Well, as we always do, we always write, as we just did rather, it's useful to place an x to the 0 next to the constant term. So we'll just simply rewrite this equation as y equals 5x squared plus 2x minus 1x to the 0. So instead of showing the 1, you just put x to the 0. Once you have a term, you can essentially assume it's being multiplied by 1. So x to the 0 is the same thing as 1 times x to the 0. For those of you that like the multiplication sign being there. But in algebra, you don't show the multiplication sign. So this is 1 times x to 0. You don't have to show the 1. So we can leave it like this. Now, if you look at this general form, on the right hand side, you have 2 plus signs. You have a term plus another term plus another term. And I'm going to rewrite this equation just as it is here with regards to the existence of 2 plus signs. So here we have y equals 5x squared plus 2x plus minus x to the 0, just to ensure it matches with the general form. Now, to determine whether the given equation, which we've rewritten as this, is quadratic, we need to show that it has this form. Comparing this equation to the general form, you can tell that it is of the general form because by comparing the coefficient of x squared, you can tell that a is 5. Coefficient of x squared here is 5. Coefficient of x squared here is a. Coefficient of x here is, okay, let's even move to the fact that we have a plus here, we have a plus here. Coefficient of x here is b. The coefficient of x here is 2. So by comparing the coefficients of x, you can determine that b is 2. We have a plus sign here, we have a plus sign here. We have an x to the 0 term here. We have an x to the 0 term here. The coefficient of x to the 0 term here is c. The coefficient of the x to the 0 term here is minus 1. You can always assume there's a 1. Therefore, by comparing the coefficient of x to the 0, c is equal to minus 1. So it's just a case of inspecting and comparing two equations. Really simple. So in conclusion, this is a quadratic equation because a is not 0, a is actually 5, b is 2, c is minus 1, and therefore it's of the general form. Now consider this equation, y equals 2x plus 3. Is this equation quadratic? Well, let's do something that we normally do, which is to place an x to the 0 term next to the constant term. In this case, the constant term is 3. And we know that placing an x to the 0 term next to it is the same thing as multiplying 3 by x to 0, which is the same thing as multiplying 3 by 1, which is the same thing as doing nothing, because 3 times 1 is 3. Now, what you notice is that there's no term involving x squared. In the general form, there's a term involving x squared, term involving x, term involving x to the 0. There's no term involving x squared. But the rule for quadratic equation is that they take this form and a should not be equal to 0. Now let's try and write this equation in this form. How do we do that? Well, y equals, let's put an x squared term plus 2x plus 3x to 0. Now for this equation to be exactly the given equation, the coefficient of x squared must be 0. Now you have to really consider this and look at it. 0 times x, 0 times anything is 0. You know, 0 times 5 is 0, 0 times 6 is 0, 0 times anything, 0 times x is 0, 0 times x squared is 0. So once you know this, you'll be comfortable with what was written here. 0 times x squared is the same thing as 0. Which means that, if you just start from here and simplify, we'll have y equals 0 plus 2x plus 3x to the 0, which is the same thing as y equals 2x plus 3x to the 0. A lot of the times in mathematics, when you have 0 plus a number plus 0, or a term plus 0, or 0 plus a term, you just ignore the 0. There's no need to write it, because 0 is nothing. So what I'm just trying to point out is the given equation in this form, where you have an x to the 0 term, an x to the 1 term, where the 1 isn't shown, and an x squared, a term involving x squared. We have that here, a term involving x squared, a term involving x to the 1, or x, and a term involving x to the 0. Now just by comparison, you can tell that a, for this equation, this given equation, which we've rewritten in this form, a is 0, b is 2, and c is 3, just by comparing the equations. Now, given that a is 0 in the given equation, this equation y equals 2x plus 3x to the 0, which was written this way, and b is 2 and c is 3, is this equation quadratic? No, because for a quadratic equation, a must not equal 0. Therefore, this equation is not quadratic. So that's just a test, but this example just illustrates the importance of this condition. It can't be taken for granted. It is one of the key things that differentiates a linear equation or other types of equations from quadratic equations. Now the last thing we're going to consider is similar to the topic of changing the subject of the formula, but all we're doing is making sure we can identify quadratic equations which is just a slight variation from the general form. So for instance, you could be given an equation like y plus 3x equals to 2x squared plus 2, and as you can see, you have a y and a term involving x on the left hand side, whereas in the general form you only have a y on the left hand side. So in order to make this equation look as close as possible to this, you want to isolate y on the left hand side, and you achieve this by making y the subject of the formula. For this given equation, you can achieve this by getting rid of this plus 3x. And how do you do that? You subtract 3x from both sides. This aspect of mathematics has been covered in the change of subject video. So subtracting 3x from both sides gives y equals to 2x squared plus 2 minus 3x. Now we have y isolated on the left hand side, and the right hand side can be rewritten in the order of the general form. You have the x squared term, then the x term, then the constant term. So how we have the x squared term, then we can have the minus 3x and the plus 2. Now we have an equation that is exactly in the form of the general form for quadratic equations. You can really tell that a is 3, and if I just further rewrite it so that we just have plus signs, you can tell that a is 2, coefficient of x squared is a, coefficient of x squared here is 2. You can tell that b is minus 3, by comparing the coefficients of x, and you can tell that c is 2 just by comparing the constant terms. Or if you wanted to use the method of adding an x to the 0 here and x to the 0 here, the coefficient of x to the 0 here, c, coefficient x to the 0 here is 2. Remember, x to the 0 is 1, and multiplying 2 by x to the 0 here is same thing as multiplying 2 by 1, which is same thing as writing 2. So c is 2. Hope this makes perfect sense. Now here's another odd looking equation. Is it a quadratic equation? Well, is it an equation of this form? Well, let's see. Now, the first thing to do is to try and rewrite it, the given equation, so that it looks like a general form, such that there's only a y on the left hand side and you have all these other terms on the right hand side. So let's do that now. So to achieve that, we simply have to make y the subject of the formula. So we want to get y to the left hand side. So the simple thing to do is, first step, a logical thing to do is to swap the left hand side and right hand side. So we're going to do that now. And that gives minus x squared plus y equals x plus 3. Now just rearranging the left hand side, or rather actually getting rid of the minus x squared so we can isolate y, we add x squared to both sides, and doing so gives y equals x plus 3 plus x squared. Now rearranging the right hand side terms in the order of the general form, so the x squared term coming first, then the x term, then the constant term, gives this. Now, is this a quadratic equation? Well, let's see. What's the value of a? A is 1 if you compare the coefficients of x squared. B is determined to be 1 if you compare the coefficients of x, and c can be easily determined to be 3 just by comparing the constant term. As you can see, a is 1, so a is not 0, and the equation can be rewritten in a form that looks like this, like general form. As you can see, we have a is 1, b is 1, and c is 3, and a is not 0. This equation is quadratic, even though it looks so odd. It doesn't look like this, but by rewriting it in the general form of the quadratic equation, we could tell that it is in fact a quadratic equation. It's the case of the general form where a is 1, b is 1, and c is 3. Sometimes you come across quadratic equations, meaning equations that meet the requirements of this general form, but sometimes they'll be such that b is 0. For instance, you can have equation y equals to 2x squared plus 3. The coefficient of x here is 0, because if I rewrite this equation as 2x squared plus 0x plus 3, I have the same equation here. Here, as you can see, the coefficient of x here is 0. That means b is 0. Similarly, you can have quadratic equations where c equals to 0. The constant term is non-existent. So an equation of the form 2x squared plus 2x will be such an equation, because this equation can be written as y equals 2x squared plus 2x plus 0, and you can easily say the constant term is 0. You can also have a quadratic equation where both b and c are equal to 0. So looking at general form, if b and c are equal to 0, you have an equation in the form y equals ax squared. So where a could be any real number, so for instance y equals 3x squared. So in other words, for a quadratic equation where b equals 0, takes the form y equals ax squared plus c, where a is not equal to 0 and a and c take real number values. Similarly, when c is equal to 0, quadratic equations take the form y equals to ax squared plus bx. And when b and c equals 0, quadratic equations take the form y equals ax squared. Again, a is not equal to 0, and a and b take real number values.